All right, this is going to be a 2-5 textbook review. I want to start off with a couple problems, and here's a quick one. Y is less than or equal to 2. We need to look at this and know that our slope is 0 because there is no x here. So my slope is 0, my y-intercept is the constant of 2. This is going to cut through the y-axis at 2. So I have a horizontal line here, and because it's an inequality, I decided that this line would be solid because it's less than or equal to. And then to decide where to shade, the y value is less than 2. So if I look at my y-axis as a number line, I can shade everything below this. My other option is to use a test point. I like to use the point 0, 0 if it's not on the line. And if I do that test point of 0, 0, and I plug it in, 0 is less than or equal to 2. So since that's true, everything shades. If it's not true, I would shade the other side. Now this one's not on here, but if I had an inequality that said x was less than or equal to 2, that's the one where the slope is undefined and it would cut through the x-axis at 2. So be very careful with your vertical and horizontal lines. All right, I'm going to go ahead and jump to number 11 here, okay? And I'm going to come back and talk about number 7. But I want to jump to number 11, and you have two options here. Option 1 is to distribute your 1/2, which is no problem because both of these divide nicely by 2. We can take a half of them. Or my other option, instead of distributing a fraction, since it's all multiplied by 1/2, is that I could multiply by the reciprocal to cancel and not distribute, and multiply by the reciprocal. And I am left with 6x minus 2y is greater than or equal to 8. In number 11, it did not specify to use intercepts like number 7 did. So I'm going to go ahead and solve this one for y equals mx plus b. So I'm going to subtract the 6x, and I get negative 2y is greater than or equal to negative 6x plus 8. And then I wanted to do this one because I want to remind you when I divide by a negative, I need to flip my inequality. So take a minute and double check that you flipped your inequality and double check your signs. So this is the one that I want to focus on. My slope is 3 or 3 over 1, and my y-intercept is negative 4. So I'm going to plot my starting point at negative 4 on the y-axis. Make sure you check for that. And I am going to do my slope of rise 3, so 1, 2, 3, run 1. 1, 2, 3, run 1. And this would be a solid line again because it's equal to. And then there's two ways I can look at shading. I like to look at this, I focus on the y equals area. So y is less than or equal to my line. So my line cuts the y-axis right here. And since we're talking about y, I'm using the y-axis, the up and down, as my number line. So no, don't think about left and right. I know we're so used to left and right because of our number line. We're looking at the y. It says y is less than or equal to this. So y is less than as I go down. So that means I'm going to shade this lower half of my graph. Now, if that makes you a little uncomfortable, the next thing you could do is do that test point. And again, I'm always going to pick 0, 0 because it's easy. The only time I can't pick 0, 0 if it's on the line. So here's my test point 0, 0. I want to know if it works. So take 0, 0. I'm going to plug it into my inequality right there. So 0 is less than or equal to 3 times 0 minus 4. Is 0 less than or equal to negative 4? No, it doesn't work. So if this point doesn't work, then nothing works. And it must be everything on the other side, so I would shade that way. All right, let's jump back to number 7. This is really important. We used intercepts in another section, and we're using intercepts here, and so we need to have that down. So there are two facts about x and y intercepts that I asked you to know. So the first fact about the x-intercept is it is on the x-axis. The second fact is as an ordered pair, that's what we have to answer it as an ordered pair when I'm on the x-axis, I'm looking for the x value, we'll call that A, and the y value is always 0. So those are the two facts. The x-intercept is on the x-axis, the y value is always 0. And remember, your answer should be an ordered pair. So go ahead and put the 0 in there, and that helps guide me to put the 0 in for y. So 5x, and that's going to cancel out, but we'll go ahead and show that just to make sure we see it. That's gone. I get 5x is less than or equal to 20. Divide both sides by 5. X is less than or equal to 4. So there it is. There's my point at 4, 0. Next thing I want to take you to, we are going to need to shade. I can't come up here and use that inequality because it's not y equals. I can only use the inequality symbol if it's solved for y. But if you look here, it says x is less than or equal to 4. So if I look at my x-axis, that would make me shade that way. So I'm going to leave that there. Now let's talk about the y-intercept. Same idea, two facts. Two facts about the y-intercept. One, it's on the y-axis, and then the second fact is that the x value is 0, so it's 0b. All right, so I'm going to take my 0 and plug it in for x, so it's going to wipe that out. So to show that, it's 5 times 0 minus 2y is less than or equal to 20. So that's gone. Negative 2y less than or equal to 20. Divide by a negative, so please make sure you flip that sign. And I have y is greater than or equal to negative 10. So my y-intercept is 0, negative 10. So go ahead and plot that point on the y-axis, and y is greater than, so I'd shade this going up. Now, we've got to draw our line. Again, this one's equal, so if it wasn't equal, I'd draw a dashed line, but this one's equal, so I'm going to draw in a solid line. And notice that both of my arrows point up and to the left. So this is the region that's shaded, all right? And my answer is anywhere in the shaded region or on the solid line. Again, if you want to use a test point, I would stick with 0, 0. If I plug that in, 5 times 0 minus 2 times 0 should be less than or equal to 20. And that is true. 0 is less than or equal to 20. So since this point works, then all the points over here work. All right. So there's more problems on this assignment, but I'm going to go ahead and turn over to the back. There's another one with x and y intercepts, so you'd use the same technique. And I want to go over the word problems next. All right, so I'm showing the textbook here. That way I can read this problem, and I have a blank piece of paper that I'm going to transfer some information on to help us. So in number 9, that's what we're focusing on here. Therese is buying 2 different types of cereals from bulk bins at the store. We have granola at $2.29 a pound. Okay, so I have granola cereal at $2.29 a pound and muesli, which I'm probably not saying right, and it costs $3.75 a pound. So something cheaper and something a little more expensive. And she has $7 to spend. We are going to use X as the amount of granola and y as the amount of muesli. So it's really important that we define our variables, and I'm going to stick with the x and y since we're graphing. I don't want to use things like g and m because it's easier to graph. So it's important to define these variables for full credit. So I'm going to write on my paper that x is the amount of granola and y is the amount of the other cereal. And just for the information, granola was $2.29 per pound, and this cereal was $3.75 per pound. Okay, so total money that she has to spend is $7. So we want to know how much of each they can buy. So write and graph an inequality for the amount of each cereal, and then there's a secondary question: how many pounds of granola can she buy if she buys 1.5 pounds of the muesli? So that secondary question is going to come after we solve this. All right, so I've got my graph paper ready, but before I can use my graph paper, I need to set up my equations. So we need to think about this. It's going to be cost times quantity. So I'm going to write this as 229 times x. And so what that is, x is the amount of granola, and it's measured in pounds. I should write that, in pounds. And this is the amount of muesli, and that is also in pounds. So I should have written that there. So when I say $2.29 times x, it's $2.29 times the number of pounds. So if I buy 1 pound, it's $2.29. If I buy half a pound, it'd be $1.13 or $1.14, somewhere in there. So this is the total money spent on granola. The cost times quantity is the total money spent just on granola. And we would add to that the $3.75 per pound, and that's the total money spent on the muesli. All right, now, sorry about the bells. Now we know she has a total of $7 to spend. That's all she has. So what she spends on this cereal has to be less than or equal to $7. So again, cost times quantity, that's total money because it was per pound, and that's the total money spent. And that's why it's an inequality, because she can spend $7 or less. The amount she spends, less than or equal to $7. Now there's two more inequalities we actually should consider. And that is the fact that x has to be greater than or equal to 0 and y has to be greater than or equal to 0, because I can't have negative pounds of the cereal. So we do want to consider these two extra inequalities. We're really focusing on this, but I want to throw this in and talk about it. Okay, now when I go to graph this, I've got this blank graph paper and I'm going to need to set it up. So the x-axis is here, and I'm going to use this as my point 0, 0, okay? So this is the amount of granola, and this is the amount of the other cereal. But I'm going to measure in pounds. Got to write that in pounds and in pounds. And then this is what I want you guys to consider. I have no idea how to number my graph yet, because I don't know what I'm really looking at. So how do I number this? I don't know until I figure out what I need. So before I get into that, I'm going to come back here. Now, I can solve this for y equals mx plus b, but just looking at it, my numbers are going to be an absolute mess. I'm not going to have a nice y-intercept, and I'm not going to have a nice slope. So whenever you graph word problems, I would like you to use your x and y intercepts. So x-intercept and y-intercept. That is going to make an easier, more accurate graph for you. So the x-intercept is on the x-axis, the y value is 0. So I'm going to take that 0, I'm going to plug it in, and so I'm left with 229x is less than or equal to 7. So I'm going to go ahead, I'm going to type that one into a calculator. I'm going to divide by that 229, so 7 divided by 229, and I get that x has to be less than or equal to 3.05, oh, I just wrote that wrong. 3.0567, and it goes on. So we are definitely rounding here. So 05. I'm going to round down. I don't want to actually follow the rounding rule. The number is 3.0567, but if I round up to 3.06, that could put me over my money. So at this point, I have to break rounding rules and round down. So that is my x-intercept. That's 3 pounds. That's the max. So if she buys none of the muesli, she can buy 3 pounds of the granola. The y-intercept is found by x being 0. Again, notice the ordered pairs. I'm going to put 0 in for x. It's going to wipe that out and leave me 3.75 times y is less than or equal to 7. So go ahead again, and let's take 7 divided by 3.75, and I get 1.86 repeating. And again, I'm going to break my rounding rule because y has to be less than this. So if I round that up, that's going to put me over. So 1.86. So you can see I did not get very nice, friendly numbers to graph. Okay, so that's as high as I need to go on my axes. So I think I'm going to count each one by a half. I could probably also count by quarters, but I think I'm going to count each one by a half. So when I go to graph this, please be careful. Here's a half. Here's 1, here's a half, here's 2. One of the mistakes is people put 1 here. So every 2 is 1 unit. So each block should represent a half, so make sure you start with that first half. All right, so those are my pounds of granola. Same thing here, 1 pound, 2 pounds, 3 pounds, 4 pounds. And then I'm going to plot my x and y intercept. So the x-intercept was 3.05. Put this right here so you can see it. The x-intercept was 3.05, so just in here, and the y-intercept was 1.86, which is just in here. Now, when I go to connect my line, it's solid because it could be $7 or less, and I do need to shade. So if you look at this, x is less than 3.05, I would shade going this way, and y is less than, I would shade going this way. Now, notice that I'm staying in this first quadrant. Remember, this is my quadrant, so this is quadrant 1, 2, 3, and 4, and the reason I'm staying in here is because my line goes past here with arrows. I'm getting into negative pounds of cereal, negative pounds of cereal. So that was this idea that x has to be greater than or equal to 0 would be an inequality showing that vertical line that's undefined, and y is greater than or equal to 0 would be in here, and that boxes it in that first quadrant. So don't go beyond that first quadrant because we're talking about a word problem here. So my solutions are anywhere in this shaded region or on the line. Now, because we're graphing, we only count by halves, I can't just look at this and pick a point. It's not going to be very accurate. So I would want to check the algebra between the numbers, but apparently she can buy 1 pound of granola and a ½ pound of muesli, and she'll be under $7. We could probably do 1 pound of each. We could do 2 pounds and then half a pound of the muesli. But again, I would always take those numbers and double check just because of the accuracy of the graph. Now, part B of this problem said, how many pounds of granola can she buy? So this was part A. Part B was pounds of granola. So many pounds of granola if she buys, let me find it, 1.5 pounds of muesli. If 1.5 pounds of muesli is bought. Okay, so basically it's how much is left over. So what I would do is, yeah, I can look at this. 1.5 pounds of muesli is right here, 1.5. So it's somewhere under a ½ pound if I look at the graph. But I want to do it algebraically. So this is the y value. So I'm going to plug it in. 2.29 times x plus 3.75 times y should be less than or equal to 7. So I'm going to go ahead and do the algebra here. And I have 2.29x plus, double check my math on the calculator, 5.625 is less than or equal to 7. Let's get that x isolated. So I'll take that away from 7, and I get 1.375. I'm going to divide by 2.29, and I get x is less than or equal to 0.6, and it has a couple zeros after it. So I'm going to go ahead and leave it at that. So here's how I would answer this. It'd be 0.6 pounds, so there's my label, of this, 0.6 pounds of muesli, or less. And that's really important because it's an inequality. I don't have to buy 0.6 pounds of muesli. I can buy 0.6 pounds or less. I could buy 0 pounds, I could buy ½ a pound, as long as it works. And that coincides with our graph. So if I was at 1.5 pounds of this, I said around a ½ pound. And so with the accuracy, we know we were close there. Okay, so I know this problem took a good amount of time, but I think it's really important to work through the word problem. So I'm going to go ahead and keep going. We're going to jump to number 19. I'll try to work through it a little faster. So we have a marketing problem here that says quarter-page ads in the local newspaper cost $200 per day. 1-minute ads on the radio cost $500. So Sheena's Lawn Care is advertising budget of $10,000. Let X be the number of quarter-page ads, so they're defining the variables for us, and Y be the number of radio ads. Write an inequality for the advertising that Sheena's Lawn Care can afford. So actually, it just says to write an inequality that's not asking me to, oh, there it is, write and graph. But we're not answering any other questions, so we're writing and graphing. So let's get our information down from this problem. So in number 19, the information is that X is the number of quarter-page ads. So X equals the amount or number of quarter-page ads. All right, and the cost of those quarter-page ads are $200 per day. $200 per day. All right, and then Y is the amount of radio ads. And the cost there is $500. So, and for 1 minute. So amount of radio ads, $500 per minute. All right, so that's our information. And she has a budget of $10,000. So that means what she spends has to be less than or equal to $10,000 for her advertising. So we want to write an inequality. So think about this again as cost times quantity. X is the number of quarter page ads, and I have it per day. So basically we're really looking at a daily ad, a minute ad. So how many of these daily ads can I have? $200 times the number of ads that I have, all right? Plus $500 times the number of radio ads. So cost times quantity, that's the total money spent on the quarter page ad. So if I do 2 days of these ads, it'd be $400. If I do 5 of these 1 minute ads, that'd be $2,500. That's all we're doing. The money spent plus money spent has to be less than or equal to 10,000. Now that's really it. That's all they want. But I'm going to remind you that the number of ads has to be greater than or equal to 0 for both of these. I can't have negative ads. So again, to set up my graph, I cannot count. I don't need to count to 10,000. I need to see what my x and y intercepts are. This one would probably be okay to solve for y equals mx plus b, but if you don't have a nice y-intercept or a nice slope, it's a little bit hard to do, because if my slope is different than what I've counted by in units, it's hard to do. So x and y intercepts are your best friend right now with graphing word problems. So the x-intercept, I'm putting in the 0, and so that would wipe that out, and I have 200x is less than or equal to 10,000. And then the y-intercept, we're going to put that x value in as 0, and it would be wiping out that, and we look at 500y. So I'm really just saying, if I don't have any of the quarter ads, how many newspaper or how many radio ads can I have? And that's the idea. You're looking at the zeros. How many can I have of one thing? Okay, so take a minute, double check your numbers and your zeros there. It's always good to be careful. And I can have 50 of these quarter page ads if I don't have any radio ads. If I have no radio ads, then I can have 20 of the radio ads. All right, so if I don't have any quarter page ads, I can have 20 of those. So now I don't need to count to 10,000 or 500 or 200. I need to count to 50 and at least 20 on my axes. So let's go ahead and set up our graph. Let me tuck this away here. Yeah, I'm out of room. Okay, so here we go to the graph. I'll just transfer everything for you. Here's number 19. This is going to be the amount of quarter page ads. And this is going to be the amount of radio ads. All right, so I want to sort of pre-count. My y-intercept was 0, 20. So I don't need to count by 10s here. I can probably count by 2s or 5s, and my x-intercept is 50. So I think I'm just going to count by 5s to keep it the same. So here's 5, 10, 15, 20, 25, 30. So make sure you didn't start on the first block as 10. 5, then 10, 15, then 20. So I just want to point that out. Be really careful with that. And I'll just go up to 60 here. Okay. On the y-axis, I'm going to go ahead and do the same. So you don't have to use the same interval for x and y. However, if I'm doing slope, I probably want to try to use the same interval. But I'm not worried about slope. I have an x-intercept of 50, 0. I have a y-intercept of 0, 20. Again, I have a solid line. And I'm going to go ahead and connect it with my post-it notes here. And then if you go back to inequalities, and we go back to when we solved, this x was less than or equal to 50, and y was less than or equal to 20. So less than 50 would have been going this way, less than 20 was going this way. So we are going to shade this in. And I'm going to go ahead and make my line a little bit better there. And we're going to go ahead and shade this in. Again, I don't have a very accurate graph. You can see some of this is not perfect. So I would definitely double check all my answers. And notice that that vertical line at x is greater than or equal to 0 and y is greater than or equal to 0 keeps it in here. Do not extend your lines. You want to segment from endpoint to endpoint here. Okay, we have one more word problem to talk about. I really want to spend the time going over these because I think they're important in some of the harder problems we do. So in number 21, let me go ahead and show that to you. A little bit harder to show due to, there we go, due to my textbook. But Amber has $200 gift card for boat rentals. She rents kayaks at $8 and canoes at $12 per hour. X is the number of hours of kayaks. Y is the number of hours of canoe. So very important to know our variables. So $200 total dollars, that's her limit. So this is another one less than or equal to. $8 for every hour, $12 for every hour, and it's not how many kayaks and canoes, it's the number of hours we're renting them, okay? Write and graph a possible inequality, and if she rents kayaks for 10 hours, how many hours can she rent canoes? So we'll come back to that B after we get this question answered. So the information we need, let's go ahead and define our variables. X is equal to the number of hours, I want to make sure I have it right, number of hours for kayak rentals. So number of hours, oops, sorry about that, for kayak. And the kayaks cost, let me transfer all my information, $8 an hour. So $8 per hour. All right, Y is number of hours for canoe rental. And the canoes cost $12 per hour. Okay, and she has a total of $200 on this gift card. So she can spend all of it or less, but not more. Now I know why everything's crooked, because I changed my camera. Okay, so here's what I'm going to do. It is $8 for every hour plus $12 for every hour. I need you to think about what this means because we're going to get into a lot of word problems in chapter 3. So it's $8 for every hour. So if she rents kayaks for 3 hours, that's $24. Total money, 12 times how many hours total money has to be less than or equal to that $200. Again, I can solve this for y, but I'm not going to get a nice even y-intercept, so it's much easier to use your x and y-intercepts. So x-intercept, I promised you we would keep using these, and so here we are, y-intercept. Okay, let's go with this. The x-intercept, the y value is 0, so I'm going to put the 0 in for y, and that gives me 8x is less than or equal to 200. Divide both sides by 8. And so I'm just going to get a decimal. I don't want to worry about just reducing the fraction. And this one, it goes nicely to 25. But if not, again, we want to just stick with the decimal so we have an idea of where it is. So there we go. The y-intercept, we know x is 0. I plug the 0 in. I'm left with 12. Y is less than or equal to 200. Y is going to be, hold on here, 200 divided by 12. And I end up with the decimal of 16.6 repeating, so I'm going to keep it rounded down. Again, I'm breaking my rounding rules because it has to be less than, so I have to keep it rounded down. So those are my two intercepts, so 16.6, and I want to remind you that my hours have to be positive for both the x and the y. So let's get to graphing this. When I go to graph this, I'm going to label my, let me try to straighten this out a little bit better. I'm going to label this the number of hours for kayaks. And this is number of hours for canoe. All right, with my x and y intercepts, I know that I have to count on the x-axis to 25 and the y-axis to 16.6. So I'm going to go ahead and count by 5s again. I think 2s, it would take me a while. If I would count by 2s, I'm going to have a more accurate graph because I'm going to have it more spread out, but we can always use the algebra to help us with our accuracy. So I'm going to stick with this. Again, you could probably count by 2s, but I'm going to stick with this. So my x-intercept that I have on paper here, my x-intercept was 25, 0. So I'm going to plot my point at 25, 0. And then my other one is 16.6. So just above 15, remember I'm estimating, so it would have been better to count by 2s. And then again, a solid line. And because both of these were less than, shading down and down and across, then my answer would be in here, and notice that it stays in that first quadrant. I've got x is greater than or equal to 0 and y is greater than or equal to 0. And so here it is. There's where my answers are. So part B had said if Amber rents kayaks for 10 hours, how many hours can she rent canoes? So 10 hours, she could rent up to maybe 10 hours of canoes. So we need to double check our math. So I'm going to go ahead and do that, but that's what the graph shows. So here is part A, and part B is 10 hours of kayak. And we want to know hours of canoe. So I'll plug in that 10. 8 times 10 plus 12y is less than or equal to 200. So that would be take away 80, and I get 12y is less than or equal to 120. So y is less than or equal to 10. So how do I write that answer to get full credit? I don't just write y is less than or equal to 10. Even if I put the canoes on it, it takes more than that. It is going to be 10 hours or less for canoe rentals. So I can't stress enough that idea of or less or more, depending on if it's greater than or less than. Okay, I know this recording is extra long, but I have one more thing I want to talk about. It's a little bit different, and it's the last 3 problems, so I'm not going to do them all, but here is what it looked like. It's numbers 38, 39, and 40, and it doesn't take much more than a minute to figure these out. So we're going to use our skills here. In number 38, it says write an inequality. Well, I need the idea of y equals mx plus b. So I need m and I need b. So this is nothing new. We've been doing it with linear equations. Now we're going to do it with an inequality. So my y-intercept is here at -5. And my slope, we have to be careful and pick some nice points. Looks like it goes to here. So I'm going to go up 1, 2, 3 units and write 1. So my slope is 3 over 1 and it's positive. So when I go to write the equation, it would normally be y equals 3x minus 5. But it's not equal right now, it's shaded. So if we just look at a quick sketch of this graph and we see that it's shaded down here, first of all, it's a solid line. Okay, so I know that. And second, it's shaded going down below. Don't look at the x-axis, look at your y-axis. It's shaded going down. So the y must be less than or equal to 3x minus 5. So that is how you write your equations for 38. Number 40, I'll just put it up here, and you can see the answer right there. This one is your horizontal line. So it has a slope of 0, right, between positive and negatives, and it has a y-intercept of -3. It cuts through the y-axis at -3, give me that y compared to 0x minus 3, and we're shading down again, and it's solid, so less than or equal to. And so you might write it simply as y is less than or equal to -3. Okay, this one in between, you can double check this, it's an odd answer, but make sure you have that it's a dashed line, it's shaded above, so greater than. We have a y-intercept at 2, we drop 4 and run +3. So make sure you double check that you have a negative slope and it's shading as you go up. All right, well, thanks for hanging in there with me. These word problems are really important. Using the x and y intercepts is key to doing them accurately.